Hi, this is Professor Hudson explaining how to use indifference curves as you need to use them for the Rothschild and Stiglitz adverse selection model. So just to remind you, indifference curves are a contour map of people's utility. So we know that on a contour map, if we're reading a map of a mountain, every place along this one of these lines, you have the same elevation. And for indifference curves, every place along an indifference curve, you have the same utility. So utility equals 20. Meaning every point above this curve gives you more utility than 20, and every point below this curve gives you less utility than 20. We also remind ourselves that there's an indifference curve through every single point on this graph. So if I choose a random point on the graph, I chose that point, I know that this person has an indifference curve through that point with some amount of utility associated with that. So maybe utility equals 35 associated with that point. And that's true of every single point on the graph. We can use indifference curves to compare utility for different points on the graph. And of course, a point is a bundle of goods. And using the Rothschild and Stiglitz model, we have a bit of a weird space of goods. We have wealth in the non-accident phase and wealth in the accident phase. So I could compare this much wealth, which might be $55,000 in the non-accident phase, and $20,000 in the accident phase, so that might be point A, to this point up here, where we have $40,000 in the accident phase and $50,000 in the non-accident phase. And I might want to know which one is this person going to prefer, point A or point B. And we know they're going to prefer point A, even though these are on two completely different points in the graph, because point A is uphill on utility mountain and point B is downhill on utility mountain. Point A gives us more than 35 utils and point B gives us less than 35 utils. So the last thing to keep in mind about indifference curves is the fact that this represents somebody's individual preferences. So that's very specific to one particular person. So each person is going to have a different shape for their indifference curve. Their utility mountain looks different. So if we're going to compare the indifference curves for a healthy and sick person, we might have indifference curves going through a particular point, and we know that any random point we pick on the graph is going to have an indifference curve through it. So we might have this point, or this indifference curve and this indifference curve, representing two different people's preferences. So the first thing we need to decide is which belongs to the healthy and which belongs to the sick person. And just like if you choose a perpendicular direction to go up the mountain, that's going to put you the steepest direction up the mountain. You'll gain elevation most quickly if you go perpendicular to these contour map lines. And the same thing is true on utility mountain. If you choose the perpendicular direction, that's the person's favorite direction. It's the direction that increases their utility the fastest. So for this person with the flatter indifference curve, they would like to move up utility mountain in that direction, meaning they gain the most utility when they gain a lot of elevation, we'll call it, on the accident state of the world. So they care a lot about how much money they get in the accident state. When we look at the steeper indifference curve, this person cares more. They want to go up utility mountain in this direction, so they care more about the non-accident state. And so we just need to ask ourselves which person cares more about the accident state, the healthy or the sick. And we know that the sick person is the one who cares more about how much they have in the accident state. And then the healthy person is the one who cares how much they have in the non-accident state of the world. So given that, we remind ourselves, what does this point represent? And I've been using alpha to represent a particular insurance package, meaning it has some amount of money in the non-accident phase, which we know is going to be their wage minus the insurance premium that the insurer charges, and then some amount of money in the accident phase, which essentially represents how much they lose minus how much, or sorry, their total wage minus how much they lose, which would be what they would get if they had an accident without insurance, plus whatever the insurance company pays out to them. So that's going to be our vertical piece of the curve. So alpha represents one particular state of the world with one particular insurance package. So we want to check several different points on this graph to understand how to think about this space. So let me give you 4 different points. So point 1 is going to be point A, point 2 is going to be point B, point 3 is going to be C, and 4 is going to be D. So insurance companies are going to have to consider, if I created an insurance package that put a person at state B, who is going to be attracted to my package if everybody's insurance package is at alpha? So I can do that by checking both different people in terms of, is this uphill or downhill on utility mountain for each individual person? So I might start with the healthy, and I notice here's the healthy person's indifference curve. So this is uphill on utility mountain. They gain utility by switching from alpha to B. So definitely healthy people are going to be included in this pool if you offer that insurance package. What about sick people? Well, here's sick people's indifference curves, and we notice that this is also uphill on utility mountain for sick people. So actually, if everyone's being offered package alpha and you offer package beta as an insurance company, you're going to attract both healthy and sick people, meaning the relevant actuarially fair line is going to be the pooling line. The pooling line is the one with both healthy and sick people. So we could just write down our relevant line here. So let's check point C. If everybody has an insurance package that puts them at point alpha, and we as an insurance company offer this package C right here, the question is, who is going to be attracted to it? So once again, let's start with our healthy people. So we're looking at this indifference curve here, and we want to ask ourselves, do these healthy people prefer alpha or do they prefer C? And we notice that C is on a higher indifference curve, so it's farther up utility mountain for the healthy people. So the healthy people are going to be attracted to this. So maybe we'll even write that down. Definitely the healthy are going to be attracted to this. What about the sick? Well, if the sick are being offered alpha, and an insurer comes along and offers C, the question is, will these people switch from package alpha to package C? And we notice that for them, it's actually downhill on utility mountain. So they would get less utility from switching to this package than they currently have. So the sick people are not going to be attracted to this package. So if we offer package C, we're only going to attract the healthy. So just to check a couple other different cases, let's check A, point A. Let's say everyone has the insurance package associated with alpha, and you as an insurer come along and you offer package A. So first of all, let's check our healthy people and see if the healthy people are attracted to point A. Well, if they have alpha, they're on this indifference curve, they would actually be moving down utility mountain, downhill, getting less utility to switch to point A. So the healthy people are actually not going to switch to A, so definitely no healthy people. What about the sick people? Well, for the sick people, here's their indifference curve. Point A is actually higher on their utility mountain, so they would actually switch over to A. So in this if we offer this package, we're only going to attract the sick people. And I won't go through it because it's somewhat obvious, but if you actually sit down and check, point D is down utility mountain for the healthy and down utility mountain for the sick. So if you offer D as an insurance company, nobody's going to switch over to your insurance. So that's essentially just not going to work if you want to insure anybody at all. And that's pretty much what you need to know about indifference curves if you're going to understand the Rothschild and Stiglitz model.